Hello everyone. In this video I want to show you how to set up a private AKS cluster and how it can help you to increase the security of your cluster. So the plan for today is, first I want to talk what a private AKS cluster actually is. I had a couple discussions with a couple development teams in the past and there has been quite some confusion, so I want to get this out of the way. Once we're done with this, we're going to create a new private cluster. Then I'm also going to tell you my opinion on updating an existing cluster to make it private. And at the end, I'll show you how we can access the cluster through the Azure CLI as well as through the portal. And now let's take a look at the components of Kubernetes so you can understand what a private cluster actually is. So here we have a high-level overview of our Kubernetes cluster, and here on the left we have the master node. In simplified terms, that's the brain of our cluster and contains everything we need for the cluster management. And then in green on the right side, we have our worker nodes. The worker nodes run our container and they contain all the workload inside the cluster. And when we talk about a private cluster, it doesn't mean that we take everything and make it private so you can't access anything. What it means is that we configure the API of the management plane to make it private. This means it's not accessible from the internet. And this makes the cluster very secure because you have to be inside the VNet of the Kubernetes cluster to access the API. But this does not have any effect on the working nodes. If you go back to our worker node here, and we have here a couple pods running, they are not affected at all. They can download images from Azure Container Registry, from Docker Hub, and they can also access the internet. Another change is that if you have the private API activated, then the worker node and the master node communicate over a private connection. This means it's ensured that the connection is through a VNet and not over the internet. In my next video, I'm going to show you how to also integrate a private Azure Container Registry to have the whole environment private and not accessible from the internet. But for now, let's take a look how to create a private AKS cluster. Here in the terminal, first we configure 3 variables. That's the name of our AKS cluster, the resource group name, and the location we want to deploy this cluster. Next, we create a resource group. And after we've created this resource group, we can create our cluster. And I'm just using the most basic configuration here. So we use AC AKS create, then we provide the name of the cluster, the name of the resource group, and then we use the enable private cluster flag. That's all we have to do to create a private cluster. And then we start the deployment, and it will take around 5 to 10 minutes, and then the cluster should be up and running, and I will be back. The cluster has been created, and now we can download the kubeconfig file so we can access the cluster. And to do this, we just use the AC AKS get credentials command. We provide the resource group name and the cluster name, and then we download the config and save it in our kubeconfig file. So far, everything is the same as with a public cluster. And now I want to show you the differences. So let's switch over to the Azure portal and see what we can see there and what is different. So on the first glance, everything is the same. But you can see the difference if you scroll down on the left side and select the networking tab. And there you can see public access to API server is disabled. And we also have a hint, and it tells us that the API is using an internal IP, and therefore all the communication between the worker nodes and the master node is over a private network. And the same when we click on public access, we can also see here the public access to the API server has been disabled. And this means if you want to access our API now, we have to be either in the same VNet or we use the Azure CLI, and I'm going to show you how to do this. But first, let's take a quick look at the VNet. So since we didn't provide a VNet when we created the cluster, Azure created a VNet by itself, and it always has the name AKS VNet and then a random number. So if we want to create, for example, a VM and use this VM to access our API, then this VM has to be in this VNet, in the AKS VNet. So far, everything looked basically the same as with a public cluster. But now if you click on any of the Kubernetes resources, for example, namespaces, then we will get an error message because we can't access the private cluster. And here it tells us unable to reach the API server, or the API server is too busy to respond. And this basically means we can't access the API over the internet. And obviously it's the same if you click on workloads or whatever we try to do in the Azure portal. And now there are two ways around. Actually, there are three ways. As I said before, we can have a resource within the VNet. This could be a VM, or you have a VPN connection, but that's expensive. It takes time to set up. You have to maintain it. So that's not a good solution. A better solution would be to use the run command in the Azure portal. So if we go down here, we can execute our kubectl commands. For example, kubectl create namespace and then a name private. And now it takes a couple seconds, and then the command will be sent over the Azure VNet to the API, and it works. So that's great. But as a developer, I like to use my own CLI. I don't like to use the Azure portal. And so now let's have a look at the terminal and how we can access our AKS cluster from there. So here in the terminal, let's clean this up and just execute a normal kubectl command as we always do. So let's say kubectl get namespaces. And there you can see we get a whole bunch of error messages. And if you take a look at it, it says the same error message we got before. Unable to connect to the server, unable to look up the URL of the API. This is because the API is not available over the internet. And what we can do now is we can use the Azure CLI to wrap our kubectl command and then use the Azure CLI to send our command through Azure to the API. And to do this, we use the AKS command invoke command. Then we provide the resource group name of our AKS cluster, the name of our AKS cluster, and in the command parameter, we provide the command we want to run. So in this case, I want to say kubectl run nginx with the image nginx in the namespace private. And this will start a pod of nginx. And this takes a couple seconds longer than if you just execute the kubectl command, because it has to wrap the command, send it to Azure, then send it to the API, and then they get the response. But as we can see, our pod has been created and we didn't get an error message. And if you use the command again, but this time we say kubectl get pod, then we should see the pod we just created. Again, it's taking a couple seconds. And there you can see our pod is running. It's healthy. Everything is working. And with this, I showed you that even though our API is private, we can still access it. So we have the security of the private API, but still the convenience of using our development tools. one downside of this approach is if you have a pipeline set up to deploy to your cluster. For example, if you have an Azure DevOps pipeline with a Microsoft hosted agent, then your pipeline will fail with a private cluster because the Microsoft hosted agent is not inside your VNet and therefore it can't access the API to do the deployment. And there are a couple of ways around. The first one would be to host the agent yourself. I can link you videos where I showed you how to host the agent inside AKS or inside an Azure Container app. Or you can also use Azure Managed DevOps Pools, which is a great solution because you don't have to manage the agent. You can just select what virtual machine you want to use. Then you can attach this Managed DevOps Pool to the VNet and it has access to your cluster. Another option would be to use GitOps. That's probably the best way when you do Kubernetes because the GitOps agent is running inside the Kubernetes cluster and you configure it with a Git repository and then the GitOps agent is monitoring this Git repository. And if something changes, this means if there's a new commit in the Git repository, then the GitOps agent downloads the changes and applies them. And since the connection is from the cluster to the internet, the connection works. And this also allows you to always have the cluster up to date, and it also prevents configuration drift. Because if the configuration changes, then the GitOps agent still compares with the Git repository, and if the Git repository has a different state, then it downloads the files from the Git repository and applies them. There are two big open source solutions. The first one is Argo CD and the second one is Flux. And both work great. And if you're interested, let me know in the comments if I should make a video and show you how to implement both. The last topic to consider is your container registry. So far, we have a private cluster, but if your container registry is publicly available, then an attacker could get access to the container registry, upload an infected container, and if the cluster downloads the container, then the attacker also has access to the cluster. And in my next video, I'm going to show you how to configure a private Azure Container Registry. And with this solution, you have your cluster and your container registry private. And then in combination with a self-hosted Azure DevOps agent, then you also have a private connection from your Git repository to the container registry and then to the cluster. This means from building the image to publishing the image to running the image on the cluster, everything is private and safe. And that's everything I want to show you for today for a private cluster. But I also have an existing public cluster, which I want to show you if and how you can update to have it private. So let's switch over to the Azure portal. And there you can see we have the private cluster, but I also have here a public AKS cluster. So if you open this one and now scroll down a bit under the networking tab, we can see here public access to the API server is enabled. This means it's a public cluster. And if you go back to our terminal, then the first thing we have to do is we have to install an extension for Azure CLI, because this extension is still in preview. The name is the AKS preview, and with the upgrade parameter, I update the version because I have already installed it in case there's a new version. So with this in place, we can now do an AC AKS update. Then we provide the name of the resource group, the name of our cluster, and then we say we want to enable the private cluster. And this is also a feature that's still in preview. And if we run this now, then we get an error message. And it says we also have to use enable API server VNet integration, but then we have to provide the ID of the VNet. And if you continue this, I got several error messages until I gave up. And the solution I've been using so far was to just create a new cluster and then deploy my applications again with the private setup and then go from there. I hope the CLI support is going to improve, especially since it's still in preview. It might be changing a lot, but for now it's quite complicated to update a public cluster to a private one. And the last thing, if you tried this out and didn't work and you want to get rid of the preview extension, you can use AC extension remove, and then you provide the name AKS preview and it uninstalls the extension. That's everything I want to show you for this week. So we have deployed a new AKS cluster with the private API enabled. This means that the management API of the cluster is not available from the internet, and therefore also the worker nodes access the API over a private connection. And this helps us to keep all our traffic secure and private. But this doesn't affect the pods that are running on the worker nodes, because they can still access the container registry or the internet. For us developers, not much is changing because we can still access the cluster via the Azure portal, or we can still use our CLI. We only have to use the AC AKS command invoke command to wrap our kubectl command and then send it through Azure to the Kubernetes cluster. What might change is your deployment. So if you have been using Microsoft hosted agents so far, then the hosted agent can't access the cluster because it's not in the same VNet. So you have to find a solution that's probably a self-hosted agent. There you have different options in Azure, or you can also use GitOps. And the GitOps agent is running inside the cluster and pulls changes from the Git repository. Let me know in the comments if you were able to update an existing public cluster to a private cluster, and also let me know if you want to see how to implement the GitOps solution, or if you have any questions about private clusters or how to do the deployment with a self-hosted DevOps agent. Thank you for watching and hopefully see you next week.